Hey guys, I am back, everyone. Not only guys, apparently, and this is the happy part. I am George, and this is another TypeScript meetup here in Munich. It's actually our second, although there were more meetups before me and Radu came into place. It's a very interesting meetup, a very interesting talk today about the game of life by Conway. I think it was a mathematician of around 70 or something that devised this game. It's a zero-player game. It just depends on how it evolved on the initial states. I think Radu, you will tell us a bit about the game before we actually start implementing this. Just note that's something that I have to tell. I'm saying in every meetup, as you see this icon here. I am going to record this meetup. No, this is me. This is a warning. I am going to record this meetup and publish it later to YouTube. So if anyone have any disagreement, please, I will do it probably tomorrow afternoon or something. You will have 24 hours to reach me through Meetup. You can find me and express your objections, and we'll see what we can do. Maybe blur your name or your image or whatever you want. That is it from me. Radu, I will stop sharing my screen now.
Don't you want to do your own introduction? I mean, I saw you prepare the slide. You can also do
Yeah, I did it. Actually, this slide, this PowerPoint is from the previous meetup. I just copied and changed some things. And the previous event, that it was the first that I was getting into the TypeScript meetup, and I wanted everyone to know who am I. Of course, many people didn't join this meetup, and it's your first now, so I could very well repeat that. I am George. I am organizer of Munich.net meetup. I was actually for, and still am, for the last 2.5 years or something. An opportunity came along the way this summer, I think, and I'm also now organizer of TypeScript meetup along with Radu that will do the presentation here. You can find me, of course, on the Meetup platform and send any message you want there, but you can also find me in Twitter, GitHub, or my blog post, which I need to blog something. I was so busy the last 2 months now, with the coronavirus situation. Things at work need to be very agile, and you're it seems like you are talking all day long. It's very weird. Yeah, anyway, so I did my presentation. Radu, now I think it's your time.
All right, let me take over.
Stop sharing and I'm ready.
Okay, let's see if I get this right. My presentation skills, unfortunately, are very primitive. Does this look right on your screen?
Yes, perfect.
All right. So as George mentioned, we are gathered here to do a quick presentation on the subject of TypeScript and Conway's game of life. I would like to explain some basic principles of TypeScript, which most of you are already aware of, and explain the rules of the game of life and why it's such an interesting test case, not just for TypeScript, but for many programming subjects. And then we will dive right into coding, where you are all welcome to code in parallel or code your own sessions, and then we'll be back once we're done with actual implementation. I did a quick test run last week. Took me an hour and a half from start to finish. It probably would take me less now, unless I decide to go on a completely different path than last time, but we'll see how this goes. Now you will see with the next slide that I have the design skills of a 5-year-old. I tried to put something nice like George has, but I ended up creating this visual masterpiece. So my name is Radu. Don't try pronouncing the last name, but unfortunately, it is also my main ID for Twitter, GitLab, and also GitHub. I'm not active on GitHub that much anymore, aside from contributing to some open source libraries, and even there, I don't contribute that much. But if you do want to find me somewhere, you can just use that. As I was just talking before the start with George, I just squeezed in the fact that I'm participating in Movember, which is this yearly event in November where men shave their facial hair, and then for the month of November they grow a mustache. You can use the link there to see the pictures I have added so far and see how embarrassing it looks. Don't have a lot of facial hair. I am the Chief Technical Officer for Fleetster, or the legal name of the entity behind it is Next Generation Mobility. We're a company here in Germany, located exclusively in Munich, and have been building the web platform Fleetster for the last 7 and 8 years or so. I started programming in '94 with BASIC. Then I got involved with PHP and JavaScript, which were the trendy languages back in 2007. Had my first taste of TypeScript in 2014 with the version 0.9. And since then, as part of our activities here at Fleetster and also in private, have been involved in collaborating with the writing or building up about 42 TypeScript-based projects. Of course, many of those, as you can imagine, are very tiny microservices. So the number, it looks much larger than it signifies, but some of those projects are very large projects with tens of thousands of lines of code. So I have seen how this technology behaves both in very small projects and large projects, and also had the experience of transitioning projects from JavaScript to TypeScript, and involved in the general transition or experience of the technology here within the technical team that we have. There are technical team here is built up of 15 people, QAs, DevOps, developers, designers, and so on. But we are very closely related to programming, most of us, and deciding whether to use TypeScript and not to use TypeScript has been a very interesting, challenging debate within our company for the past years since we started experimenting with it, to finally reach the conclusion that the benefits of TypeScript outweigh the disadvantages that we experienced so far, and that many of the disadvantages we experienced were related more to the early adoption of the technology and are no longer relevant, as is often the case with new technologies. So that's a quick intro on my background and additional information if you want to use. So today, let's start with some basics of TypeScript, which I'm sure all of you or most of you already know, but doesn't hurt to throw it out there. TypeScript is an extension of the JavaScript language, or what's called a superset. That means it contains all of the features of the JavaScript language. Technically, it also includes some features that are not available in pure JavaScript, like in Node or browser-based JavaScript, because it implements specifications that are further ahead of the curve. But in addition to basic JavaScript functionality, it provides a significant amount of additional functionality that allows you to express things that are not available in the base language, such as types, obviously, but also a lot of other things that are available there, such as abstract classes or various other functionalities that would be difficult to express in pure JavaScript, although TypeScript itself compiles to JavaScript, so you can use it wherever you decide you need it. We ourselves here have used it successfully server-side, client-side, and mobile, so we can attest to the fact that the technology is useful in whatever environment that you use JavaScript. And now moving on to Conway's Game of Life. This is a quite old programming exercise or game, which has seen a lot of variations over time. Its main interesting aspect is that you can write the exact same game using pretty much all of the programming paradigms. You can do object-oriented programming, functional programming, test different development. You can use whatever methodology of programming, and it provides you with very clear objectives and challenges in terms of data structure, processing, and so on, that highlight the advantages or disadvantages of different programming techniques, but also allows you to practice those techniques. Interestingly enough, in the test run I did with TypeScript and Game of Life last week, where I had some of the junior members of our technical team join us, we actually ran across many of the typical advantages of TypeScript. And I'm hoping that I will run into the same problems, or I will just artificially manufacture those same situations, because it was interesting to see that even such a simple game circumstance like the Game of Life helps to highlight the situations where TypeScript is useful, but also where TypeScript can cost you time. And let's hope we experience a similar situation now. But if not, I will just reproduce those circumstances. So unless anybody has something that they would like to ask or add at this point, I would actually dive right into the code. Anyone want to put forward a question? Nice. All right.
Yeah,
Let's
I think we
get
can.
to it. Let's close this one. Let's close this one. Let's go. Let's start with just highlighting what the rules of Conway's game of life are. So everybody's on board who may not already be familiar, although you can just Google Conway's game of life and you find a nice Wikipedia entry that also highlights the general rules of the game. You start off with a existing state of your world. The game of life simulates the sequences or the generations of an existing world and how it evolves over time. That's where these little animations pop in from. I'm trying to hide it. Go away. No, I'm missing half my screen now. All right. Well, so there are 4 primary rules, which actually can be reduced to 3 or expressed in 3. So you start off with b-dimensional grid, where each square either contains a live cell or a dead cell, or you can think of it as populated or unpopulated. And every new generation of the world, a transition happens where, first of all, any alive cell or square that has less than 2 live neighbors will die from underpopulation. Any live cell that has 2 or 3 neighbors will live on to the next generation. And any live cell that has 3 live neighbors or more than 3, will die from overpopulation. And any dead cell or grid square where there are exactly 3 live neighbors will become alive through reproduction. And as you can already figure out, this can be rewritten specifically in 3 rules, which are that any alive cell with 2 or 3 live neighbors will move on to the next iteration. Any dead cell with 3 neighbors will move on to become a live cell in the next generation, and everything else will die. And these are the basic rules of the game. There are obviously a lot of different variations of how you implement your world. That's one of the interesting tricks. You can have a fixed width world where you decide to have specifically a grid of 10 by 10, 100 by 100. Or you could have an infinite world, which is a bit trickier to code. And then even if you do have a fixed size world, you can decide what happens at the borders. That increases the complexity of the game. You can decide that whatever is at the edges of the world just drops off. So it's like a flat earth type of thing where if you walk off, you fall off. Or you could wrap it around, wrap the edges around, and then have the ends connected to each other, which requires a bit of extra coding. You can see if there's extra time at the end of this coding session to implement some of the more advanced world behaviors. So now let's stick right into it. I've actually created a repository last week on my GitLab profile, which I think is already public. I have a master branch there, but I have now created a new branch and deleted all the stuff that I have created there so that we can start from scratch. So first off, what you do if you want to get started with TypeScript? Well, probably I'm going to use Yarn, although you can also use NPM if you want. Just we in the company here are using Yarn, and I've gotten used to it. So I'm going to start by adding TypeScript to the project. I screwed something up. Right. La, 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 la. Yay. All right. Now this by default won't do much. Let's add a TypeScript file. Let's just call it. And let's just do a console log for starters. Let's add a script ifs where we compile and then we run. Yeah, let's see if this works. Pretty sure it won't work. Dun, dun, dun. It won't work because adding TypeScript to the project is insufficient. We are missing a TypeScript config. Without it, the TypeScript doesn't really know how to treat this. So we need to add a TypeScript config file. Luckily, WebStorm, I'm not sure how many of you are using WebStorm, but WebStorm comes with quite good integration into TypeScript. So already comes built in with a bunch of stuff that you're probably going to use, such as live compilation and clean up your files. So you can see here that I've added a TypeScript config file thanks to WebStorm. So let's see if this does something now. And there we go. Now we have finally done something. Now, the interesting thing to realize is you are not able to directly run TypeScript files, not unless you use something like TS Node, which acts basically as a wrapper around TypeScript and just compiles and then runs TypeScript. In reality, you are always going to be compiling a TypeScript file and then running the JavaScript representation of that file. WebStorm by default will compile in place and it will hide away all the actual code. So if I tell it to show me what's all of the files, I can see that it has under Game of Life has actually provided me with the JavaScript file and also the map from JavaScript to TypeScript, which you can see what the output is. Of course, in this case, since I only added something that's exactly the same in TypeScript and JavaScript, it hasn't really done anything interesting in terms of compilation. We'll have a look at the JavaScript files more in detail once we have written a bit more code so that we can see what TypeScript actually does with our code after it compiles it. So let's probably add also a git ignore. Okay, here we go. Finally managed to move this. Create a git ignore. Do I have a template? TypeScript? No. Let's ignore JavaScript files specifically because I don't want to commit those to the repository. So I don't want to ignore map files as well. So let's just push this add TS. Okay. Let's see if it's correctly ignoring the other ones. Yep. No, it doesn't care about the JavaScript and the map, which is what we wanted. So now that we have a running in an environment, let's do a little bit more here. So let's think about this. How do we want to handle it? So the first thing that we're going to need is to figure out the data structure that we want. Let's start off with the simplest version, which is the fixed dimension for the game world. We're just going to represent a matrix in JavaScript, and then we're going to see if we can extract a type out of the game world definition that we're probably going to be reusing in a lot of different places. So I guess step one is to find out how we're going to do that. So I guess we will have a constant, which is going to be starting world, or let's start world to be a bit simpler.
Radu, can I interrupt you for a second?
Sure.
Marius is asking if they are supposed, I mean, if they could potentially clone the repository as you're working and try to work with you, or if this is for a later use. Why did you push it to a repository?
I mean, technically you can already clone the repository, but it contains a solution that I wrote last week. I could start pushing and you guys could also pull, just that I'm using not the master branch, the Meetup branch, but that's a good point. Let me get the exact endpoint, because I think I can point you also to the, didn't I push it? No, I forgot to push. Here we go, let's refresh. Okay, where is the clone?
Yeah, Marius, exactly that. You can pull whatever Radu is doing. You can try to code as with him, or you can just watch the presentation. I mean,
where is the? How do I write something somewhere?
Sorry.
How do I write something in Zoom?
In Zoom.
I was hoping to leave the repository endpoint. Okay, here we go. So if you want, you can clone this, switch to the Meetup branch, which is where I have just started working, and you can take that. You can also separately code along, just your own ideas, and you can listen in if you want. You can also just follow the presentation if you want. One thing we could do, if you have WebStorm, WebStorm has a funky new functionality that was launched about a month ago, which is called Code with Me. So I'm going to publish now the link. So if anybody actually wants to, they can join actively in my WebStorm session, and you can start writing inside. Let's see if this has a positive impact. So where's link, WebStorm, Code with Me link. Now, if you want to use this, you have to install the Code with Me plugin. Yes, I mean, technically you have a 30-day trial. So if you just download WebStorm now, you can use the free version for 30 days. You can also install the plugin, which is called Code with Me. And then you can click the link. And I think that's it. I'm not sure if the link works without WebStorm, but I think you probably need to install WebStorm first. Or you can just try clicking the link and see what happens.
Yeah, that also works.
Although, we'll see if that has a positive impact, because having a lot of people trying to code at the same time within the same interface is probably not a good idea. But you can just also clone the repository. I'll try to commit and push frequently. It's a good programming practice anyways. All right, so starting world. We said matrix. That means it's an array of arrays in JavaScript sense, because we don't actually have matrices. Is there a JavaScript matrix structure? I mean, I remember set and map. I don't think there's something that's close to, no, not this one. This one, map object. So we have a map and a set probably. No, so let's just stick with the classic. We're gonna have something like this. Let's TypeScript complaining. And then, okay, sorry. No, it doesn't work like that. Wrong language. So let's start with how big do we want to do this? Let's decide world size. It's gonna be 10, so that we can render it in a nice way. Let's create a function that actually initializes our world. That's probably a good idea. But let's just for now write it. So we're gonna do just a small thing here. Let's do it. World size. Classic 4. There's lots of different ways you can do this, but I'm just gonna take it easy. Let's use true and false. That's probably easiest. We could also use 0 as one, but let's go with true and false. So every one of you so we're going to populate our matrix with just a bunch of true false. Okay, so let's put a function around this. Get world, generate world, instantiate. It's a bit long. Create world. This sounds nice. Okay, so now it's not world size anymore, it's size because I'm passing it as a parameter. I generally would like to try to keep things functional. I'm a big fan of functional coding, at least in the last couple of years, since getting much more with buddy with React. Although sometimes this doesn't go as well as we would like with JavaScript. Some things just want to be object-oriented. All right, so now we have a function, we have a world, but we don't see anything. So let's start with the typical visualization we can do, which is let's just console log our world and see what pops out. It's probably going to be quite ugly, but let's see what spins out. So we have an unreadable display, but at least it's giving us something. So that's not too bad. Let's go with the quick commit push so that other people can have access to it. All right. Next thing that I would like to do is to visualize our empty world, to have a more visual representation of our world, because this will be very useful in debugging all the different issues we will likely experience as we write the rest of the code. So we want some kind of visualization that will allow us to see this. But I also like to focus on the code that I'm writing. So I think I'm already going to extract this create world, despite it being very basic, into its own file. So I'm going to take this and I'm going to create a create world TypeScript. And I'm just going to export this function that I've created. And I'm then going to be able to import this from there. Actually, WebStorm gives me a built-in prefill, so all I have to do is Alt-Enter, and then it's already taking it from the new file that I have just created. But before visualization, let's already look into something that is TypeScript related, instead of just writing JavaScript code. Let's look at types already. So let me extract this create world function into its own file. So what I would like to do next is to be able to define the input parameters of create world and the output parameters. As this is one of the main things you will do with TypeScript, you will define the type of parameters your functions or objects accept or expect, and the type of return return type of your functions, so that it's clear what is needed or expected. So for input, it's easy. The first thing we will do is we will define the type of size, which is a number. So in TypeScript, if you want to express the type of something, you will use the, what is that? Dots, two dots. What's the English term for this symbol? Huh.
That's colon, I think.
Colon. No, colon would be this one. This is colon, this is semicolon, and this one.
Yeah. This is colon, this is semicolon, the other is comma.
Comma. Ah, right. Okay, okay. Number.
It's a double comma.
Sorry?
Let's see what the internet says. The magic of internet. No, sorry, this is semicolon.
It's colon.
Now it's telling me the definition.
It's a colon.
Yeah, looks like you're right. All right, so you put
a poll in the chat.
yeah. So you put the input parameter as you would normally have within your function. You put the colon sign, and then you put the type. In this case, size is easy. Ooh, somebody's connecting. All right, let's see if this works. Miki or something. Okay. Now you could write in if you want. Right, size is a number. That one was easy. Start world. Okay, this is an array, obviously. Okay, TypeScript does what's called type inference. So in this case, telling TypeScript that start world is an array is unnecessary. Unless I know that start world is not a simple array, like I am doing it here, but a more complex object. Because in reality, start world is meant to be a matrix that contains Boolean values. So I can tell, I would like to be able to tell TypeScript what start world will need to be. And so I need a type for start world. And now is the tough part about how to express a type. There's different ways to define types. The most extensive use of a type is called an interface. Now, this was one of the interesting challenges that I faced last week, which is how to define an interface for my world. So normally you would have an interface. Let's say you have an object. Let's say our world is not an array, but an object that has some property with string value and Boolean prop false. And I'll have lots of these similar objects. Then I could define an interface world, which will say it expects some prop to be string and Boolean prop to be Boolean. And then I can declare that this world should be of type world. And this works. The problem is, if my object that I'm trying to define is an array, of stuff, then I need a different one. I mean, right now, this type is just a regular array. But assuming that inside of here, I have stuff like similar stuff to what I had before, this is a more complex array. You could do that by saying this is an array of world, because I had defined this one as this. This is telling TypeScript that this object, let's call it worlds to be a bit more explicit, expects an array, which inside of it will contain objects of the type world. When you have this notation, you are expressing the type of the things that will be inside of the array. This is, I mean, if I would have, let's keep it even simpler. Let's remove our previous interface and let's say that this is going to contain true, false, true. Then I can tell TypeScript that this is the type of world by saying this is an array of Booleans. And then TypeScript will not allow me to do worlds of position 4 is, here you will see that it complains. It says, you told me this is going to be an array of Booleans. Why are you now giving me strings? You can't do that. Let's make it even more explicit like this for those who prefer this notation. So how would you say if you had an array that contains both Booleans and strings? Well, you can tell TypeScript that you want that by using the type notation, which allows you to know that the array will accept two different types, Booleans and strings. Now this is okay, but if I decide to push something else in, like a number, it will complain yet again. Because it says, you told me it's going to be a string or a Boolean, and now you give me a number. And you could say, okay, I also accept the number. At some point, if your array is sufficiently mixed of different types, you're going to say, okay, no. I don't want you to tell me what types it is. I just want to let you know that this is an array, and I'm going to put in the side of the array whatever it is what I want, which is not generally advisable because this is unusual. You might want to instead put in objects or so on, and then you would define the type of objects you're going to put into your array. But let's say you just want an array and you want to have it usable for anything. TypeScript contains the any type, which in certain linting configurations is simply not allowed or advised. So this option basically allows your array to accept anything inside of it. But it doesn't allow you to rewrite the worlds with a number. Okay, first of all, because I've made it a constant. But if I was allowing it to be rewritten, as you can see here, the type is maintained, as in, even though I'm overriding the previous value of worlds, TypeScript is remembering the original type of this variable and expects you that you will maintain the type. It does not normally allow you to override a variable with a completely new type. I could override it with just an empty array or with an array that contains something, but I would not be allowed to override this with an object or something else because I have declared its type as a certain way, unless I decide to override the type as well, which you could somewhere, I think. Okay. How about this?
Radu, Mario is asking if you could declare a class instead of an interface as well. Your initial code that you were declaring an interface and setting it up as a...
Not exactly. I mean, you can declare an interface that a class can implement, but a class is not the same as a type. You can have a type or an interface that defines how your class should be structured, but you wouldn't call that an interface. You could create a class for worlds, and then you could have the world object being an instance of the world class. Yes, you could do that. And the class would implicitly act as the interface, but class and interface are not the same. An interface is just used to define your type, and the class has a lot more functionality or capability in it. It doesn't just constrain its object, unless you use an abstract class and then have another class implement that one. Unless I'm mistaken. So don't take me as the clear, decisive source of information for TypeScript, especially from the experience I had last week. I have to admit that I've realized the starting phase of project configurations has been generally in the last years done by my colleagues. So I have generally only had to deal with TypeScript at the deeper end and with the difficulties or challenges there. And I realized last week that I didn't remember so many of the necessary early steps in making use of TypeScript. So, but let's
sorry,
yes.
Maybe I'm just using the microphone. It's maybe easier. Is it comparable to the interfaces and classes I'm writing in Java or I'm using in Java that I'm using in TypeScript, or is it slightly different?
Classes in TypeScript are similar to Java classes. Yes. TypeScript is a way to gain many of the benefits of strongly typed languages, and most of it is derived from the Java language. So they are very similar and the capabilities are compatible. But an interface is not the same as the Java interface. There, the terminology is, as far as I know, not equivalent. Classes in TypeScript are almost equivalent to classes in Java, especially in terms of concepts like static and class definition and instance of a class, and all of those concepts are exactly the same. But an interface in TypeScript is helping you to define a type, and interfaces in Java have different capabilities. You would have a class that implements interfaces, for example, and extends multiple interfaces.
Like availabilities or functionalities implemented with interfaces.
Yes, yes.
Okay, thank you.
I mean, you might be able to use some equivalent functionalities from TypeScript interfaces that are also present in Java, but I have not seen them being used for the same purpose in TypeScript. So, closing off this deviation that we were doing here, let's get back to the key point. So we were trying to define our type for world. So what we know is that this one, let's start by writing it here, is going to be an array that will contain arrays that will contain Boolean. And I can also declare the return, I can also now declare the return type of this entire function to be of the same type, which is array of Boolean. But this is a bit ugly, as you can see here, because I mean, if everywhere where I declare an object that's meant to implement our world type, I have to write array of Boolean, it's gonna be a lot of duplicated code, very verbose, and more importantly, if I decide to change the data structure that I use, I would have to manually change it everywhere, which is not really wise. So the question is how to extract this. Well, okay, if you're using WebStorm, you can automatically extract the interface. And that's like the cheat that you can use. But the important part is that you don't want to declare an interface here, because an interface is meant to define an object and the contents and properties of an object and what that object should implement. Or an interface should define what a class will need to have, such as what methods or what properties a class should have. But in this case, this is just a primitive type. There is no complex object here. It's just an array of Boolean, which means what we really want to define is a dedicated type for ourselves. So we're just gonna call this world. And as you can see, it's very simple. You literally just have the word type, you define your world, and then you define what it is expected to be in terms of type. And then every single implementation of this can now use the notation of this new type that I have created, which is world, which is very convenient in terms of managing the data structure, but also making sure that nobody does any mistakes with regards to what they're passing in or getting out. So now it would be interesting to see what this code will result in after it is compiled. First, let's see if it still works. Still works. All right. So now let's have a look at what came out of this. So one interesting thing that you might be able to observe here is that type is gone, because the types and interfaces that you define in your TypeScript code are not necessary for the actual runtime of the application. They are necessary there so that TypeScript can provide the benefits of a strongly typed language by doing type checking on your code and warning you before you actually push anything that you have problems in your code, providing errors for what you're attempting to do. But the types themselves and interfaces are not practically necessary for the actual running, which should just be pure JavaScript code. And you can see that it even retains a lot of the overall code structure, so it is not that unreadable as you might expect of compiled code. Although there are some funky things that you would normally not add in your JavaScript code. All right, let's add this. So what did we do here? I guess here we just added the types. Add types to create world function. All right, so now we can go back to trying to have a nicer representation of our world. So let's create a function. Render world is probably a good one. So now we have another interesting thing. My object here, world, is of type world. And I want to also make it clear that this new function that I'm creating, which is called render world, expects the return type world. So I'm just going to do this, and it doesn't work. The main issue here is that the type that I have is in the other file. So how do I make sure that my type world, which is likely to be needed everywhere, is globally accessible? Well, we're going to define a global definition file so that, well, okay, practically there are two ways of doing this. If you have a type or interface that you need to use in one file and another, there's two ways to do it. One is you define it wherever it is and export it. So I could export this type from here. And then I can also import it in here. That's one way of doing it. And if you have local types that will be used in a couple of files, you would normally declare an interfaces file where you would define your type. A common convention for interfaces is this .d, which refers to definitions. And then you would put this type there. And then wherever you would need it, you would import it from there. So this is a common pattern that you will see in many implementations of TypeScript. But if you have a much larger program and this particular interface is reused throughout your program, you can declare a global type. As far as I remember, the convention is global.d.ts. So let's see if I got this right. I'm going to put this here, use the old file that I don't need anymore, and then I should be able to skip this path. Come on, no? What am I doing wrong here? Maybe it's something in the config. Let's see, because I had this problem last time as well. See what the master branch says.
What was the suggestion from WebStorm with?
No, the suggestion, as always, is that it imports it from that file. So if you do that, it will just take it from global, but that wasn't what I wanted. I wanted it to know that it's a global. And I thought that this was in the config. But I guess not. What did I do? First, let's see if TypeScript still runs, because that's a good test. Sometimes the TypeScript that runs in WebStorm shows problems that are not actually happening when you run TypeScript in, but that doesn't seem to be the case. Yep. Let's just see what I did in the master branch. Somewhere around here, I must have solved this one. So I definitely have without the export. Okay, fine. That's interesting. So the problem was that I had decided to export. So if you do that, apparently it's no longer detected as a global style, global definition. If you just do this in the global DTS file, then it works. So interesting. Let's see if this works in compilation. And yeah, it seems to still work. Okay, fine. So what did we do now? I added a global type. Was that it? Yeah. And extracts world type to global and creates render. All right. So where were we? Let's hide away the stuff we don't need. So let's see if we can find a nicer rendering of this world. So Let's do X and zeros for now. So I'm using the quite explicit fors, even though there are nicer coding options here, but might as well be, take it simple, keep it simple. So I want to log something to the console, but then I want to write a line. So that means let's instantiate a line here, which is empty. And then if world cell is true, then I'm gonna add to the line O. Otherwise, let's do a X, and then let's do our. All right, so I've written some very ugly code now, but let's see if it works. Well, it gives us a bunch of X's, so that's definitely something. Let's make this a little bit simpler. Let's do this. No, that's ugly. Let's do a literal. Is there a switch from WebStorm? No, there isn't. So then I'm just going to write a literal. So line is going to be whatever was there before. And then it's going to be no, I don't need this. I can just do a plus here. We'll have to see if this is better or worse, but okay. So if it's true, then we do 0, no, O, otherwise we do the X. All right, so let's see which one of this or this. Which one is better? I'm getting the feeling the second one.
Less characters, more readable. I mean, the less the better.
Yeah.
By the way, Radu, there is a question from Vakar. Forgive me if I'm pronouncing your name wrongly. He's asking if for global type, you should add anything in the config file, which I doubt, right?
I didn't need to. I thought I would. So my original instinct was that I would need to specify it somewhere, but apparently this is some kind of TypeScript convention. So in the end, I just needed to declare the type in this global.d.ts file, and TypeScript is automatically picking it up. So the answer is no, I didn't need to add something. And yeah, I should have a look at the chat. I'll keep it open from now on so I can.
Yeah, well, that's okay. That's no problem at all. You can focus on your code. But since you opened your chat, there is a suggestion from
a nice suggestion.
Code.
Yes. There's quite a few optimizations you can do. You can do a map of the map if you want. The wrong character here. Oh no, it was the other way around. We said O is true and X is false. Because then if you're gonna do that, you can also do this. Technically, you can turn the entire thing into a single line, but then it becomes significantly less readable. And later on, we're going to do something with the console log so that we can represent the world in the console to make sure that it is actually rendering as a sort of little animation, but we'll do that later. So let's see what pops out now. The join by default adds a comma. So we need to tell it not to use a character. Array join by default adds a comma in between the items. So if you don't want to do that, you have to give the empty strings here. And now we have these here, which is pretty good. All right. So we have a render world function, which is pretty concise for now. And I'm going to be excessive about this, and I'm going to extract even this one into its own function, because I anticipate that we will make this a little fancier later on. So render world. Come on, TypeScript. Here we are. Okay, let's commit this and render world file and implementation. All right, so we have a create world and we have a render world. The only problem with this is that the world that we're creating in the beginning is empty. So whatever rules we write will be meaningless because an entirely empty world will stay empty. So we need to actually put something in there. We need to have something that controls our initial game state. So normally for stuff like this, initial configuration, I guess JSON is probably a relevant way of representing stuff like that. So let's just go with that approach. No, nothing here by default. Fine. So initial world JSON. The question now is how to represent our initial world. We could represent the full world where we would do an array of arrays, but that's going to be a bit much. So I think it's easier when you want to instantiate your game to just specify which positions you would like to have alive. So I think an array and then having just coordinates inside is probably an easy way of expressing this concept, where we could do something like X and Y, something like that. Or we could do 1, 2, just straight up pairs. Which of these two approaches would you prefer? The one where we define an XY object, or the one where we define just coordinate pairs? Let's see if anybody writes something.
Yep.
So object or pairs?
Well, I'm usually a fan of objects, but pairs seems to be a clearer solution for this one.
Okay. It's also going to make the declaration a bit more concise. So let's put in some coordinates in here so we can have something actually visible. And let's see what pops out after this. All right, so I have an initial world JSON now, and I want to use this. So I've created an empty world, but now I want to actually populate that with the initial game state. So first of all, I needed that initial game state. So I would import initial world from, and here we're running into the first piece of trouble, or not the first, another piece of trouble, which is that TypeScript doesn't import or accept JSONs for import statements by default. Of course, you could do this instead of using import. You could just use require. But I find that a bit ugly. Okay, and yeah, it doesn't realize that I'm in Node. Whereas where is the Node? Okay, so let's add the type definitions for Node. Right, I think that's the, yeah. Okay. And now it's just a device. It's no longer an error that says you probably should use import, because yes, generally you don't want to mix import and require. I am not a big fan of doing that, even though I've seen it in a few places, unless you have to do programmatic require, which is somehow inside of your code. That's also generally a rarity. So how can you turn this into an import? Well, once again, TypeScript comes to, WebStorm comes to our help. Or not. What was that? Okay, well, I'll just do it like this. But this doesn't work by default because you have to add something to your TypeScript configuration in order to be able to do that. Sure, where is it? It doesn't actually give me an option. It tells me what to do, but then it doesn't actually do it. That's great. Maybe here? Well, I can just add it myself. So you need the resolve JSON true, which for some reason is not there by default. I haven't yet understood why. But if you want to be able to import JSON into your TypeScript code, you have to tell it that you want to be able to do that. And then it's working. Now it just complains the fact that I'm not using it, I think.
Shouldn't be in the curly brackets?
I'm not sure because it's no, that wouldn't work because you'd put something in curly braces if you specifically export something. So if you export something that this is a named export, then you can import it with this way. If you export a default, then you would just import it with without the curly braces. So if I do, I think it would work like this. Yes. Then I can import this like this. A JSON is not a TypeScript export. So the whole file is exporting not multiple things, but only one thing. And now I just realized what the problem is. Everything that is exported from initial world is what I need. And the way you would do that in ES imports is you would say, give me everything as initial world. Because initial world does not expose a default and does not expose named exports. So I cannot do something named from there, and I cannot just do initial world, because when you import stuff like this with this statement, the TypeScript import is looking for a property called default inside of this that would be exported, which it isn't. So what we really want to do is take everything that is exported from that JSON file and then declare it as a variable in our file called initial world. So now we have the content of the JSON file. Now it's more about actually using that to populate our initial world. So we have another array. And then actually let's extract our coordinates. This is called destructuring. What that means is inside of initial world position I. So if you look at the actual, so if you look at this position, when I'm asking for initial world value 0, I will get this array. And then I can ask to extract from this array using this notation, position 1 as variable X and position 2 as variable Y. This is not actually a functionality of TypeScript. This is just a functionality of modern JavaScript. You can extract or destructure the properties of arrays or objects by using the appropriate notation. If I had an object which would have properties X and Y, and I would like to get the access to those values without having to do .x or .y, I can just say, give me value X and Y from this object. This is called destructuring the properties of an object, and the equivalent for array was the one that I was showing you before. If I have the values 1 and 2, I can say, hey, I want that 1 and 2 extracted in variables X and Y. So I can just say, I want X and y from this array. And that's what I'm doing up here. So now I have x, y of my initial world, which need to be set as true values on the world that I have created. So world x, y should be true. All right, so now we should have a slightly different rendering of our world. Let's see what pops up. Oh, no, wrong one. This one. You can see some zeros and x's. Okay, they're a bit hard to spot because of all the x's. So let's change how we represent or how we render the world a little bit, because the x's are making it hard to actually see properly. So that's a little bit better. I guess the O is fine as a representation of a live cell. Or we can use a different icon that I used in the base branch somewhere. Let me just see. I use different names for everything in the other branch. Now I need to actually find the, where did I do rendering before? Log world was the name. Let's use this icon, see if that one's a little bit nicer. How about this one? Yeah, okay. All right. So we have a little thing that initializes the world. So what did we do here as initial world JSON for initial world configuration? And then a slight adjustment to world rendering characters. What else did we do here? Add types, node types, and changes. And lastly, I did something else. Whoops. What else did I do here? Add oh, that was a long commit. Okay. Let's start actually putting some rules into this game, because so far we've just been instantiating and rendering. So let's get to actually implementing some actual generations or transitions of our game world. All right, so I'm rendering the world, and now I'd like to do something with it. Well, let's do one transition first, and then we can implement extra logic for doing multiple iterations. So the first thing that we need to do is to apply some of those rules. Let's start with, where was it? No, here we go. Let's do the first one, which is survivors. So let's create a function which is get next world, which accepts a world and returns a world. There's a lot of worlds in here, as you can see. Did I set this one? Yes, I did. Okay. And then let's just call this next world with world. Let's change this to, let's do an constant. We're going to clean up this code once we actually play around with it and are done, but I wanted to just be explicit and not focus on code structure just yet. All right, so we're calling next world. TypeScript is already complaining because I said I would return something and I haven't done so. So for now, we're just going to do this, which is obviously a lie because I haven't actually done anything to the world yet. But let's think about this. Well, what I'm going to need for sure to define the next iteration is to create a completely new world, the next world. So let's do that. Next world is, I have a function now to create worlds, and we're going to have to keep the same size. But I don't want to keep using this world size, especially because here I already have local access to something, and I want to avoid using variables or parameters outside of the scope of my functions to keep it as functional as possible. So I'm going to rely on the length of the old world to define the size of the next world. Now I don't need to specify the type of next world because TypeScript will automatically infer the type from the return statement of create world. That's one of the nice things. So now if I return next world, it's not complaining, it's accepting it. But the only thing that I have done now is I created a completely empty world. So if I do my rendering now, I get one world that has stuff and one world that doesn't. First world that has stuff and then completely empty world. So this is obviously not okay. I'm missing the cells that should survive. So we're going to probably extract a function out of this later on, but for now, let's just do another for. There's going to be a lot of fors in this implementation. There's alternatives to doing that, but we're going to stick with lots of fors for now. All right, so I'm iterating. No, I'm going through the wrong place. I don't want to iterate through the next world because what I really care about is finding the live cells in the old world. Let's actually use that as a convention to make it much more clearer which one's which. So I'm going through every cell in the old world, and now I need to decide to do something, and I'm checking for survivors, which I guess is only relevant if the cell that I'm looking at right now is alive, because I'm looking for keeping the ones that are alive. So if the old world position, actually, let's do it in reverse. If it's not true, so if this cell is dead, just continue, move along. Otherwise, I need to figure out if this will make it into the next world. So in order to do that, I need to know how many neighbors this thing has. Let's not keep drilling into this one. Let's actually make a function that will calculate get neighbors. Is probably a good one. So old world, and then for specific position, which in this case is this one. Actually, I don't like using I and j in this case for something that effectively represents coordinates. So let's use x and y instead. I think that's more representative of what this would be. So the rule was if this is 2 or 3, if I'm not mistaken. So if a live cell has 2 or 3 neighbors, it will survive. So then I need to know how many neighbors it has. And then if those neighbors are 2 or 3, then finally the next world, same coordinates, should be true. In order to avoid, I guess, issues with data structure, we could also, instead of doing this, copy the value from the old world. Not sure which of these is better, but I think this makes it a little bit clearer that this operation is copying data from one instance to the next. All right, so now we're going to need this get neighbors function. All right, so, and this is going to return a number. So I guess, as usual, we have to do an iteration. What I'm writing now, if you're appalled by it in terms of programming efficiency, don't feel too offended. There are definitely much more efficient ways of implementing this algorithm, but right now, programming efficiency isn't really the main focus. All right, so let's start off with 0 neighbors, right? And then I'm looking for somebody who is sufficiently close to the world, the XY coordinates that I'm looking for. Okay, so then I cannot use XY again. I need to use different naming. So let's call this compare X. No, look X. Look X. Let's use an object instead. And then now that I'm using an object, I want to make it clear the type of object that get neighbors expect, which is going to be an X and a Y. All right, so I'm going through that, and then I'm looking for things that are within a certain range, but not exactly. So if this is specifically the cell that I'm looking for, then I don't need it. So if X equals cohorts.x and Y equals So now I need that distance. So let's do the distance has to be smaller than or equal to 1. For both coordinates. And I screwed something up. This is not a const. This is a let. Okay, well, I have something now. Is this going to work or not? Well, let's see. If anything makes it into the next world, because now I have a function for doing that, then I have succeeded. Because I think at least one of these has, yeah, this guy has 2 names. Is that a name? No, wait. Those 2 are connected, but not, oh shit. None of these are connected. There's only pairs of 2, so they all die anyways. Let's add something else. Let's add one here. No, let's put one here. Which position is that? Probably, what is that? 3, 4. Let's try 3. I think it's more like 4, 5. I'm not sure if I got that one right, but let's see what pops out. No, I added it to the wrong position. I wanted to put it here. I guess I need to flip them. 5, 4. No, that's probably wrong. No, it's too low. Yeah, too low, too low. How about this? Yeah, that's better. So this guy should have lived. This guy, this guy, this guy. A lot of them should have lived. Nobody lived. I screwed up the function. So it said get neighbors. If neighbors are 2 or 3, then you live. And then return next world. And then here I said if the difference between x coordinates is less than 1 and the difference between y coordinates is less 2 or equal than 1, then I have neighbors. Unless they are exactly equal, in which case ignore me. Wait. What the hell did I do here? I was supposed to check. Well, it should have actually given too many neighbors. Yeah, that's the problem. I forgot to actually check if the position is true. So if there is something in that cell, so that meant it was currently treating all positions around the cell that I was asking for as alive by default, which obviously meant that this would give always 9 neighbors. Here we go. We have something. Why did this guy die? It only had 1 neighbor. Okay, good. I guess that worked. All right. So let's do some code cleanup. Let's extract this into a method, which we will call set survivors. And since I like extracting stuff in different files, let's put this into its own file. All right, all right. Let's do now iterations. No, wait. Let's do reproduction. All right, so now we need to add the cells that will be created as a result of this game state world. So, reproduce cells. Functions should generally represent an action that they will perform. That's why I called this one set survivor. So I guess we could call this create new cells, I guess. So let's already create a file for this. And I just realized that I think this one didn't set types correctly. See, it set the types that it could infer. So you can see WebStorm tried to use TypeScript in order to figure out the types of these objects, but I don't want to use this ugly array. I want to actually explicitly use the type that I have defined for these objects so that I don't have to manage the data structure later on. And now, oh, wait. I started writing a lot of code before I actually committed something. So let's do that. Let's commit the survivors part because that one was already pretty good. Ignore this. So what did I do here? So add a new function to set survivors in the next world instance. Generates the next world instance and renders it. All right, now we can move along. So what am I going to need for create new cells? Well, it's probably going to be similar to this set, this for here. So what was the rule set? Any dead cell with 3 live neighbors becomes a live cell. So that means I have the opposite of this. I only care to check dead cells. If the cell is alive, I can just skip this check. I need neighbors, and then I need it to be exactly equal to 3. And here I cannot use this because it's not about copying data from old world to new, but I need to create or to set the new value to true. But I now need access to this get neighbors function. So let's extract that from the other file. Or is it? Here. Okay. So you are out. New file for you. Okay. I mean, the only part that I'm not a big fan of is, as you can notice, these methods that I have created here, create new world and set survivors, are not entirely functional because they mutate the object or the parameters that is provided to them. They are changing the content of next world. So if you want it to be purely functional, each of these should instantiate their own object and then return the new one. But I feel that's probably excessive, especially in terms of performance. It has only an advantage in terms of theoretical code structure because it allows us to stay purely functional, but the practical code performance is drastically worse. Right, so I create new cells next world. So now the output of our thing should be slightly different. Whoa, that looks like a lot of stuff. Is that right? Huh, okay, interesting. Yeah, it looks like it fits interesting block got generated here. All right. So adds function to create new cells in next world. Extracts get neighbors. Anything else I did here? Nope, pretty specific. All right. Okay, but now so far we've just done one and then the next iteration, which is not a lot. So we would also like to be able to control how many iterations will be run. Iterations, or let's play God a little bit and call it worlds to create. Let's go with 10 iterations for now. Probably the whole world will stabilize by that point. Normally, any of these games either end up with no cells or just a couple of cells that are stable and do nothing. So I'm just gonna have a nice little 4 somewhere around here. Actually, let's take this get next world out. This doesn't have to be here. Don't need these anymore. All right, so let's see. This is instantiating the world. You can probably extract this as well. Get initial world. So I don't need this and I don't need this, which makes this a little bit cleaner. So I'm getting my world, I'm rendering it, getting the next world rendering, and I would like to create a number of worlds. What's your problem? Oops. See, this is a good example of where TypeScript comes in handy. Right now, this code is broken. It just doesn't work. TypeScript won't let me actually move forward because it will highlight that I forgot to actually return something. I created this method that was supposed to return something, and I even said it will return something, but I forgot to add the return statement at the very end, which breaks the rest of the code entirely. Defining what you expect your functions to receive and return early on helps make sure that you don't screw up the implementation. So let's see if everything is still working. Yep, okay. Let's do another quick commit of this without you. Improves code structure by extracting defined functions. Okay, worlds to create. So, well, I have the initial world. Let's just do a 4, another 4. The only thing is, this is going to render me a lot of things in the interface. So, well, first, let's see if it works. We already now noticed that this configuration, wait, no, I screwed something up. This configuration is not meant to be stable. This value here should die off, and as should this one. What did I screw up here? Oops. I'm always passing in the world, the original world. All right. Well, fine. Let's call this let. because we need new instance, and override the instance. And now let's try it again. Ah, interesting. Is that stable? That thing feels like it has, no, it's, ooh, it does a lot of fancy things. Nice. Okay, but that's not very nice or easy to visualize this way. So let's add some timeouts. And no, let's start by doing a console clear inside of our render before we actually render, so that it's always in the same visual position. Okay, that doesn't help. Oh no, wait, what? I thought it doesn't clear do that. Pretty sure clear is supposed to. Okay. That's strange. But even if that was working, the problem would have been that I don't have any delay between the different renderings of the world. So let's do something more fancy here. Let's add a wait, an async. So first I need play game, let's call it like that. Oops. Okay. The only issue here is I want to do an await after we render so that we can see what's visible. Before and after, wait. Before. I think I'll do it before to make sure that I can at least see this one. So set timeout resolve. Let's go with 1 second. And you have a problem. I forgot the word new. Okay. No, that doesn't look right. It shouldn't be the interface. I don't think that will work. Oh, it does work. Nice. Not too shabby. Okay. So improves world rendering function, adds iteration, multiple iterations to game of life, and implements new play game function. All right. I guess we're done, at least with this part. So let's see how we're doing in terms of time. 1.5 hours, like last time. Okay, I can, wait, what was the original schedule? See if we have still time left. No more time. Okay, I was gonna show you the issue I ran into last time, but it takes a bit to set up the the case so that you can see what went wrong. So I guess we'll do that another time. So now we can move to the last part of the meetup, QAs, and perhaps any other solutions that somebody else would like to present if you have managed to code something in this time, or if you have questions. So.
Very cool, actually, that we end up with a working solution.
You weren't expecting that.
Yeah. I mean, it's a complicated thing. Of course, there are a lot of things to improve, and you can invest on that and do it very complicated. But yeah, it's. I know that it's notoriously hard actually to code like while presenting, because you need to, I don't know, watching others coding and every mistake and thinking at the same time. But it requires a lot of preparation and skills. So yeah, I think it was very impressive. I really enjoyed it, and it's one of these presentations that it keeps the interest high all the time, you know.
Thank you. Yes, I agree with what you said. Normally coding live can be a very daunting experience. I've done it in the past as well, and that's probably one of the advantages I have. And yes, in the past, not necessarily with Game of Life, but with other things that I had to do, I did not always end up with a working solution. Although of course, these sessions are more about the exercise and the experience. But I have also indeed learned about making sure that I have the right preparation for this and have sort of run through the idea of how I want to handle the coding before actually getting to it. Even though in this case, the way we solved this is different than what I had done last week. Not by a lot. A lot of things are similar, but the get neighbors function is different. Many of the names of the functions are different, and a lot of like other differences I have introduced here. But I wouldn't have been able to, especially because in the first session I did last week, I spent a lot of time debugging TypeScript basically, or understanding why something is not working. So I think about 30 minutes out of the 1.5 hours session that I did last week, I spent just searching about what did I misunderstand about type definitions and so on. And it was quite useful for me to refresh my memory about many of these things. But also one of the things that you always have to keep in mind when you talk about any technology in the JavaScript ecosystem, including TypeScript, there's always an inherent cost that you have to pay before it starts paying off. In this case, for TypeScript, it's about configuration of your project, it's about understanding types and so on, and the benefits normally only start to pay off later. So I mean, in this case, as you saw, there was not a lot of debugging that happened. Many things went and worked straight out, which is, as
because
you know,
you were prepared.
Yes, but what I've noticed is that I tend to experience a lot less issues when I'm using TypeScript compared to when I'm using pure JavaScript.
Definitely.
Because TypeScript is implicitly forcing me to solve those problems much earlier, or to notice them much earlier. And even when I do have them, it makes it easier to isolate where they're coming from. Or my advice to many people is that even though there's a cost to understanding and learning TypeScript, it's something that you should want to pay, because it's much more pleasant to be engaged in the development experience, in the creation of code, rather than spending most of your time in the debugging and bug fixing phase. And since TypeScript is effectively shifting some of that energy, it tends to motivate you as a developer. So an interesting takeaway, I guess.
Yeah, completely agree. This strongly typed sort of approach. Yeah, there is this any keyword or whatever, these good things. But anyway, it solves a lot of problems, and it prevents you from trying to solve a bug during final execution, during runtime, let's say. You are facing the problem much earlier, which is much easier to solve them.
Although I guess we will talk much more on the subject of pros and cons in the next meetup that we will set up, where I have the sort of quite comprehensive results of our own debates. last debate that sort of settled the subject internally for our company of whether we use TypeScript or not lasted a full half a day. It was quite a heated debate, I guess. But after quite a long journey of exploring the advantages and disadvantages. Right. Anyone else have questions of any sort which you would like me to answer?
It seems there are no questions, I guess. This was an entry level talk, right? That's why we had to create all these things from scratch, so it would be easier for everyone to understand step by step the process of.
Yes. And the talk about the pros and cons will not be in this particular style of workshops. That's really just about outlining the results of our own investigation. Okay, well, it was good to have you all here. I hope you enjoyed the session and that you found it useful. If you have questions or stuff like that, you can always drop me a message through either Meetup or other means. I'd be happy to help. And I'm personally going to be trying to organize more meetups for both of the groups, for TypeScript and for the JavaScript coding night, even though they have slightly different formats. And so they'll probably be separate in the future. But looking forward to seeing all of you again in the future.
Perfect. I really enjoyed, and I think many people enjoyed it already. So we will continue with the series of these meetups, I think, because they are really, really interesting. We'll see if we can have a joint meetup at some point with the JavaScript group, or yeah, we'll see how it goes. In any case, have a great evening, everyone. And yeah.
Same to you. Bye-bye. Have a nice evening.
Bye.